Welcome to lesson 28, problem 1. And we are continuing our work with graphing quadratic functions that we know have x squared as a highest degree term, and they graph, at least for right now, as when they're y equals x squared, which all the ones we're working with are, they're going to either graph downward or upward as a parabola. Okay, so let's get started with what we need to do when the form is standard form. This is something you really want to memorize and really think about because it's going to come up every time you're looking for the x-coordinate of the vertex, or you're being asked for the axis of symmetry, or you're being asked for a maximum or minimum, which we will see in word problems. So I'm going to zoom in a little bit just so you can see this a little bit better. But negative b over 2a is going to always be our x-coordinate of the vertex. In this case, as a reminder, this is how we get A, B, and C. So the x-coordinate is going to be negative 8. Let's redo that a little bit. So the x-coordinate of the vertex is going to be negative 8 over 2 times 2. So it's negative 8 over 4. So the x-coordinate of our vertex is at negative 2. So we just simply did negative b over twice a. Now, to get the y-coordinate, one of the important skills in algebra is knowing that once you have the x value and you have an equation, you can substitute in to find the y value. So we have 2, and in for x, we're going to put negative 2. We're going to square it, plus 8 times negative 2 plus 2. So when we simplify that, we will get y equals, the first thing you're going to do is that negative 2 to the second power. Because of order of operations, exponents come first. So we're going to get y equals, and it's going to become a negative 2 squared is a positive 4. So we're going to get an 8 minus 16 plus 2. So I simplified each one of those expressions, and that gives us a negative 8 plus 2 is negative 6. So the x-coordinate of our vertex is negative 2, and the y-coordinate is negative 6. As we discussed before, the axis of symmetry goes right through the x-coordinate of the vertex. So in this case, it's negative 2, and we're going to graph that right now. So let's look at the point negative 2, negative 6, right here. Sorry, it's this point right here. And then this is going to be our axis of symmetry right through the equation, right through the x-coordinate of x equals negative 2. So it's a vertical line. All right, the y-intercept. As we know, the y-intercept is obtained by putting 0 in for x. It's the only way you're going to end up on the y-axis is if x is 0. Super important skill to know. All right, so you put 0 in for x, and when we look at this, once again, we're using our equation. You don't have to do any work because when you put 0 in for x, that becomes 0. That first term, the second term becomes 0 as well because you're putting 0 in for x. The y in this case is just equal to 2. So we know our vertex is at the point 0, 2, so we're going to graph that. And already we have our vertex. We already know that our graph is going to look better than that, but let's make it go through those 2 points. But it's going to be this U-shaped graph, and that's half of it. To get the other half of the graph, we can kind of envision it, but what we know is that the vertex and the axis of symmetry can serve to help us. Once we know that y-intercept, we can go to the other side of the axis of symmetry to get another point, which in this case would be the point negative 4, 2. And when you think about what that's going to look like, there is our graph, and we're done. All right. Thanks for joining us here today at Engage Math. See you next time.